Okay, today we're going to look at multiplying and dividing radical expressions. So we're going to be dealing with radicals and square roots and stuff again, except we're going to be multiplying and dividing them. So we just got to go through a few of the rules on how to do that. These typically are pretty easy to do because it works very similar to when you multiplied and divided exponents. So let's go through a couple of review questions here first. So if we have two radicals are two exponents being multiplied. Remember, we multiplied the front numbers. 4 times 3 gave us 12, and then we multiplied the x's, but when we have x squared times x cubed, remember the rule was to add the exponents. So multiply numbers, add exponents, and then when we divided, we did the exact same thing, except we divide the numbers. So 12 divided by 2 is 6, and then we subtract exponents. So 4 minus 2 would be 2, 3 minus 2 would be 1. So divide the numbers, subtract exponents. So the same thing still applies when we're dealing with radicals. The only thing that's different now is we get a square root involved. And there could still be x's and y's, but let's just look at some basic number ones first. So when we're multiplying radicals, we have 4 root 3 times 2 root 5. Just like we did with the 4 times 3 in the front, over here we do the same sort of thing. We multiply the 4 times 2, so that gives us 8. And with square roots, we also multiply the numbers under the root. So 3 times 5 is 15. So that's it. So 4 times 2 is 8, 3 times 5 is 15. And the only thing that's different now is we need to simplify the square root if possible. In this case, root 15 is good. It doesn't break down any further. So the same sort of rule for dividing, except we divide. So 8 divided by 4 is 2. 48 divided by 12 is 4. And in this case, the root 4 we can simplify, right? Root 4 is just a regular 2. So 2 times 2 is 4. So that'll be the final answer for that one. So multiply the front numbers, multiply the root numbers, and simplify for dividing. Divide the front numbers, divide the root numbers, and then simplify as well if possible. So let's look at a couple harder ones. So if we have a square root that has x's and y's involved, so let's look at one of those. So if we have 3x, so 2x root 3x, and we're going to multiply that by 3x squared times the square root of 5x. Okay, so do the same thing, multiply the front numbers. So in this case, we'd get 6x cubed. Multiply the square root numbers, so 3x times 5x would be 15x squared. And in this case, we can simplify it because the square root of x squared is a perfect root, and the 15 we can't do nothing with. And the square root of x squared, we'll just simplify it to an x. So we have 6x squared times x, which would be 6x cubed. Root 15 would be our final answer. Okay, so it works the same no matter whether there's x's or regular numbers and so on. One other example or a couple examples to be aware of is what happens if there's numbers missing. So if I have 2 root 5 times root 8, right, we have a number in front of the root 8 is missing. It doesn't have a number there. So remember, with any case like that, always just think of it as being a 1 if there's nothing there. So we'd have, in this case, we'd have 2 times 1, which is 2, 5 times 8, which is 40. And in this case, we can break down the 40 into 4 and 10. And our 4 would be 2, so 2 times 2 is 4 root 10. Okay, so the key idea is if there's a number missing, just think of it as being a 1. And it would work the same way as if I went root 3 times 2 root 5. So we'd have, actually let's just go root 3 times 2. Let's get rid of even root 5. Okay. And actually, let's even put a number in front. So if I had 3 root 3 times 2, so in this case, the 3 times 2 is 6, and we only have the one root, so same sort of idea. Think of it as being like a root 1. So you'd have 6 in front, root 3 times root 1 would be root 3, and we're done. So your final answer would be 6 root 3. Okay, so it works pretty easy when you're multiplying and dividing. Just simply multiply the front numbers, multiply the roots, and divide. It works the same way. Let's try a couple harder ones. So sometimes, just like when we did multiplying before, you'd have brackets involved. So let's look at one where we have 2 cube root of 4. So cube root this time, but still the same rules apply. So let's suppose we have two things in brackets like this. Okay, so we need to multiply them the same way, except now we've got to multiply. We have to FOIL it out. We have to multiply both things. We have 2 times 6 is 12. 4 times 7 is 28. And then we need to do the same thing for the second one. So 2 times 2 is 4. So 2 times negative 2, so negative 4. And then 4 times 2 inside the root is 8. So we're done the multiplying. Now we need to simplify. So will any of the roots simplify? The first one, cube root of 28, doesn't. It doesn't divide by 8. It doesn't divide by 27, so we can't do nothing with it. But for the second one, cube root of 8, does simplify. It's just a regular 2. So we'd have 4 times 2, which would be just 8. So our final answer should be 12, cube root 28 minus 8. Okay, let's do one more a little bit harder. So if I give you 2 sets of brackets being multiplied, something like that. So just remember, when you're multiplying these, you need to FOIL out all 4 combinations. So you got to multiply those 2. So that would be 5 times 2, which is 10. So we'd have 10 root 12. Then multiply the first and the last, so we'd get minus 20 root 4. Then we got to do the 3 root 3 times both of them, so that one would be 6 root 18. And then the last one would be minus 12 root 6. Okay, so we've done all the multiplying, so now we just got to see if there's anything that can be simplified. So go through each one at a time. So the 12 we can break into 4 and 2, or sorry, 4 and 3. So then the root 4 becomes just a regular 2, so we'll have 10 times 2 root 3, which is 20 root 3. The second one, root 4, is just a regular 2, so 20 times 2 is 40. So that one's done. The next one, we can go 9 and 2. So that would be 6 times 3 root 2, which is 18 root 2. And the last one, 12 root 6, can't be simplified any further, so that's it. And in this case, none of them can be combined. We got a root 3, a root 2, root 6, so we can't do anything. In the event that some of those were the same roots, we could use our adding and subtracting rules to actually combine those further. Let's look at one more dividing question. So with dividing, same thing applies, and you can actually divide more than one thing. So let's try one of those. So if I give you 18 a cubed b squared times 48 a to the 6 b to the 3, and let's subtract 12 a to the 2 b to the 2, and let's do square root of 9 a to the 5 b to the 3, and we're going to divide by 6a squared square root of 3 a to the 4th b to the 2. Okay, so it looks like a complicated question, but just break it down one at a time, do your division. So let's divide the first fraction. So 18 divided by 6 is 3. A cubed divided by a squared would be a to the 1. B squared, there is no b in the bottom, so b squared will stay the same, just b squared divided by 1. Do the square root, so 48 divided by 3 is 16. A to the 6 over a to the 4 would be a to the 2. And b3 over b to the 1 would be b to the 1. b3 over b2 would be b to the 1. So that's the first fraction. Now we do the same thing with the second one. So 12 divided by 6 is 2. A squareds cancel. We get a b squared left over. And then the second root we have 3. 9 divided by 3 is 3. A to the 1, b to the 1. And that's it. So we've did all our divisions. Now the only thing left is, can we do any simplifying? And with the first fraction, or the first square root, we can take out a 16 and an a squared. Those are both perfect roots. So those would cancel to just a 4a. So we multiply those, we get 12a squared b squared root b. And our second one can't be simplified, so it'll just stay the same. And we're done. So that would be the final answer after you do the division. So multiplying, you multiply the numbers. Dividing, you divide the numbers. And then in both cases, always simplify as much as possible at the end. And that's all.